So hope you can see my screen and listen to my voice. If you can please confirm on the chat, we can go ahead with today's topic. And meanwhile, if you have any questions in yesterday's or previous session, please let me know. All right, thank you. So we were discussing about the integrated transformations. In the last session, we were talking about the integrated transformations, and we completed data transfer, date generation, effective date. We have to look at hierarchy flattening, and yeah. So we have to look at hierarchy flattening. We have to look at history preserving, key generation, map CDC. We saw that one. Pivot and reverse pivot. We saw that, and we need to look at table comparison. So these are the pending transformations from data integrator, hierarchy flattening, history preserving, key generation, and table comparison. So we will look at a scenario here. We will look at a combination of transformations where we can use, right? So we'll look at first hierarchy flattening. So if you look at the description, it says flattens hierarchical data into relational tables and produces a description of the hierarchy in vertical or horizontal flattered manner. So what is hierarchy and what is a vertical and horizontal flattered manner? So as we're all aware, if something is with a parent and child relationship, then we call that as a hierarchy, right? So let us say A, then B, C, then D, and E, and F. So let us say this is a hierarchical data that we have. Right, so A is parent and B and C are children, right, are child nodes, and then D, sorry. So let us say this is the hierarchical data that we have, right? So looking at this, we can easily understand, hey, this is hierarchical data. And if I want to, give some notes here, so I call this as senior manager, and this one as manager and lead, right? So for a better understanding, and this one as senior consultant, sorry, consultant and a trainee, right? So let us say this is the hierarchical data. Like A is a senior manager, B and C are its children, and B is a manager, D and E are its children, and C is a lead, and F is its child. So if you want to flatten this structure, one way you can do it is a horizontal flattening, right? And the second one is a vertical flattening. So these are the two mechanisms in which we can flatten. So if I do a horizontal flattening, so I can say A and its parent and child relationship, and what is it? And if it is a vertical flattening, I can say what is the depth between A and E. right? So what is the depth between B and A? What is the depth between D and B and A? Who are the ancestors? Who are the descendants and all stuff? So I have a similar data with me. Somebody has a question? Right, so I have this flat file where I just put that in the flat file with the diagram that I had here. So I just put that in the flat file, saying that parent, child, parent description, and child description. Now let us go and add this flat file here to data services. So to add a flat file, what we'll do, we'll go to the Formats tab, then select the flat file, go for New. I'm giving the name flat file hierarchy source, then go to the folder and select where it is present. It's present in my source folder. Then select the file name by clicking on the drop down. Sorry, by clicking on the folder icon, not the drop down. So it's a tab delimited file. Select the drop down here for the delimiter and say the type of delimiter as tab, and then skip the row headers as yes. Right, so I see my file properly here. Just click on save and close, and my file is added. Now let me go and create a job. So I call this job as job underscore h flat, hierarchy flattening, and then I create a data flow, df underscore h flat. Now I will make this file as my source. So if you just look at the data, so this is my data. I have A as manager, B and C are children of A, and then for B, D and E are children. For C, F is the child. So now let us go to the transformations tab, go to integrated transformation, and select the hierarchy flattening, drag and drop it into our this one, data flow. Connect it with your parent child file, source flat file, and open it. Now if you open a hierarchy flattening transformation, there are three areas here. The first one is schema n, which represents your source structure. The next one is your schema out, which will represent your target structure. So this schema out changes based on the type of flattening that you select. So either you select a vertical flattening or horizontal flattening, it differs. So if it is a vertical flattening, right, so let me just show you the difference. So parent columns, right, you can drag and drop the parent column here. So just for a convenient naming convention, I kept it here. So let us say on an employee table, so employee number, you will call it here, and manager ID column, you can call it here. So manager can be an employee too, right? He is also an employee, so he will also be present here, and his boss will be present here. And the final level of an organization is a person who reports to himself, right? The CEO of the company or the top node of the company. So till that level, every person should be present in child, and his boss will be displayed here. So just for detail this thing, if you have any attributes related to parents or child, so you can drag and drop them here. So I just gave them as description. So if you look at the data, one is your parent description, which is manager, senior lead, right? Senior lead and lead. And also we have the child descriptions like lead, developer, junior developer, and trainee. Right, so just drag and drop them, and this will consume, system utilization space, because for each and every record it is like breaking it, and then it is going to loop within the data and cross-check how many levels of hierarchy is there, what is the relationship between the parent and child, what are the intermediate nodes that are present. So it will do all the calculations. So that is the reason why you have uh, run as a separate process, right? And the second thing, when you especially look at a hierarchical data, is there is a possibility of getting a cycle. So when I say cycle, so if I say F reports to some G and G reports back to A, so if I say something like this is a cycle here, right? C reports to A, F reports to C, G reports to F, and A reports to G. So this is not correct. So if in case sometimes you'll have that data till a particular criteria is met. So generally on an organization chart or general hierarchies, this is wrong. But sometimes these iterations should be there till a particular level is met, and once that is done, it will come out of the loop. So if in case you have such data, you can set this one do not abort in case of cycle and generate rows, cycle rows. So how many cycles that it has generated. So based on that, it will generate the rows. So vertical flattening, automatically we are checking the maximum length and the path between the parent and child. So just click on validate. So first you select vertical, drag parent to parent, parent description to parent description, attributes, child to child, and then attributes to attributes. Then just click on validate, and you will see the columns here. So if you look at the columns, we have some columns that we haven't created. So one is right. So if you look at these things that we haven't created, so one is ancestor, dependent, depth, right? Root flag, leaf flag, and then description. So you can ignore these two descriptions. They are just the columns that we had here. So whatever the description we give for parent and child at that level, it will give us. So let me just drop this into a table and save it in the target data store. Connect with hierarchy flattening transformation. So generally, when you do this hierarchy flattening transformation, you also need to mention what type of flattening that you are using. So one is vertical and the second one is horizontal. So I'm not mentioning because I'm using the same transformation to uh, go for the other one as well. So you just need to drag the parent to parent and child to child, it from the drop down here, and then drag and drop the attributes to their respective parent and child attribute boxes. And once you are done, you just need to click on refresh and you will see your schema out. Now I connected that to a flat table structure, a template table, and I'm executing this job. Right, so my job is successfully done, and the expectation, just give me a second. Uh, 1 second.
Okay, okay. Yeah, I can hear you.
Yeah, Raghu, request you to go on mute, please.
Okay.
Naveen, please give Raghu organizer access and help him to be on mute. And Raghu, if you have any questions, you can just ping me up. Right. Thank you, guys. So now, if you just click on the magnifying glass here and look at the data, now I have this structure created with ancestor, descendant, then depth between the ancestor and descendant. If the ancestor or is the one that we are looking at is a root flag. So when I say root flag, right, something at this level is a root flag and something at this level is a leaf flag. So the bottom line of the hierarchy will fall into a leaf flag and this will be my root flag. So I'll be cross-checking here. So is that a root? Is that a leaf? And what I'll be looking at is the descriptions. So if you just look at the data here, so we'll just go and pick some random F. Just a second, I guess it is showing some bad data. Yeah, it's good. So if you look at this current node that current row that I've selected, it's A and D, right? So if you look at this, this is A and D relation. So the depth between A and D is 2. So A to B and B to D, 2 steps. And then A is at the root node and D is at the leaf node. So if you look at this, A is the ancestor, D is the descendant. The depth between them is 2 levels. A is a root flag and D is a leaf flag, and A is a manager and D is a developer. Right, so in this flat file I gave A as a manager and D as a developer. So you can flatten in this structure. So this is called a vertical flattening. So it will automatically calculate the depth, calculates the depth between the parent and child nodes. And the next one that we have is a horizontal flattening. So in a horizontal flattening, you need to just mention what is the depth between the nodes, right? So you need to mention how many levels of this tree is there, hierarchical tree. And if you just click on validate, it will change. The schema out is changed now. So it says what is the current leaf that we are looking at and at what level it is, what is there at level 0, level 1 and level 2. Since we mentioned 2 levels here, so if I mention 2 levels, the hierarchy it will be at 3 levels. So the depth is 1 and 2, but level wise it will be level 1. From here to here it is level 2, and from here to here it is level 3, 3 levels. Right, so then it attribute descriptions will be there. So you can just ignore these 3 columns. Right, if I just remove them from here, I'll not get these 2 descriptions. So just let me delete this because we already know the data. Right. So this looks proper. So anyways, my target table is a template table. It will be dropped and recreated. So now re-execute the job. Right, job is successfully done. And now you go and look at the data here. Now this is a different hierarchical flattening that we have, a horizontal flattening, where I have a current leaf. So let us say I'm looking at leaf A. So this leaf is at level 0, right? So I'm doing a horizontal flattening. So level wise flattening here. So I'll first go and look at this and its description. Then here, where it is present, what is its level, what is its description, and so on. So A is at level 0, uh, and on at level 0 A is present, and level 1 and 2 nothing is present. If you go to the last node D here, so D is at level 2, uh, right? A is at level 0, B is at level 1, and D is at level 2. So you will see the complete line here, A, B, and D. So this is a horizontal flattening of the data, right? So there are two levels in which you can look at this data. So generally we remember this diagram as hierarchy, and when we think of the hierarchical data, we will not get it in this way, but we will have the repeated data present in both the columns, the parent column and the child column. So in that case, if you have a hierarchical data, so this is how we can flatten them and provide more meaningful information to the end user. So if he says, like, I have some hierarchical data with me, and I'm finding it difficult to understand it, so we can just ask him, like, what will be the maximum level of hierarchy? So what is the depth of the data? We'll just ask him some fundamental questions related to the hierarchical flattening, or that we require here to make this possible, and then we will go and ask him, like, what we can do for him. So how is he looking at the data? So what is the depth level that he is looking at, or what is, like, is he looking at each and every level and he wants to get an understanding what is at level 1, level 2, level 3, or he wants to understand its relationship as well, parents, descendants, depth, and all these things, ancestors. In those cases, we can go and based on his requirement, we can flatten these structures and provide him a more meaningful information. Right. So that is hierarchy flattening, and next we will look at a combination of transformations, history preserving, key generation, table comparison, query transformation as a combination here, and we will talk about a scenario. So let us say, so you guys must have heard about the delta mechanism in SAP. So on SAP, delta mechanism means, so I'm just going to some basics because we have people from non-IT background as well, so don't mind me repeating them. So when I say a delta mechanism, so what is a delta mechanism? So if I say I have a table here, all right, this is my source and this is my target. So this will go through a daily load. So whenever I do a daily load, right, I don't want to do a full load. So let us say I have these many records, right? I don't want to do every day. I don't want to do a daily load. So let us say I loaded this data one time. So I call this a full load. From tomorrow or next load onwards, whatever the newly inserted or updated records, right? So let us say there are 20 insert and 15 updates. I don't want to load the entire data back to this one, but I can just load these additional 25 records into my target system. There are 10 inserts and 15 updates. 15 existing records are updated and 10 new records are inserted. So rather than doing a full load, I just go and do this 25. So this mechanism is called delta mechanism. So how can I identify that 10 are inserts and 15 are updates? So the general mechanism that we will follow is delta is done with a timestamp. Right, so you can use a timestamp and compare. So whenever you load a record into the target table, you maintain a timestamp. At the same time, when a new record is inserted or updated in the source table, so a new timestamp is created for them. And based on that, this timestamp is greater than this timestamp, pull those records and push them here. So this is a general delta mechanism that we follow. So there is something called as automated delta, and since BODS will do a cached comparison, right? So the entire image of the source data is taken into the cache and it will compare it with the target. So we can also do an automated delta mechanism. So automated delta, I will not do any changes on my job. So it will just run and it will pick whatever the newly inserted and updated records and just load them into the target table. So if you have a question that can I use that for huge volumes, yes, we used it in some project, but it is directly proportional to the RAM that is available on your system. So just keep this in mind whenever you have a huge volume and complex operations. Just cross-check your RAM space, temp space that is available on your system, and if it is good, then you can go ahead and do this one. So let us say this is my employee table. And I'm trying to do a bit complex operations here. First one is table comparison transformation. The second one is history preserving. Prior to that, it is a query transformation, and then key generation, and then it goes to my target table. So let me just complete this framework so you can easily understand this. Right, this is a scenario where we can use it directly in any project. So first I will be doing a query transformation and then followed by a table comparison, and then table comparison is followed by a history preserving transformation, then a key generation, and from there to my target table. Right, so this is my scenario. Now let us just go and look at the descriptions of these transformations. Oops. Alright, so let us go and look at the descriptions of these transformations. So first one is table comparison. So what does a table comparison do? So if I look at this one, it says compares two data sets and produces the difference between them as data sets with rows flagged as inserts, updates, and deletes. Right? So we already spoke about it when we are talking about the mass transformation. So when I say a table comparison, it has two data sets. One is your incoming data set, or which is your source data set, and the second one is your target data set. So if you look at the diagram here, so it is overlapping. Oh, sorry, I have selected all these three. So you can just ignore these two as of now, key generation and history preserving. So if you look at the table comparison transformation, diagrammatical representation, it says it has two data sets to be compared, my source and my target, or my input data set and my target data set, and produces the difference between them. So it will first compare what is there in my source and what is there in my target, and then it does a comparison between the source and target, and if it finds new records in my source, right, it will take all the new records and bundle them into a bucket and flag that as insert. if it finds updated records, changed records in my source to compare. So those records are already there in the target, but some of the values are changed. So it will pick all those records and put them in a bucket and then flag it as update. So if it finds some records that are not present in the source but are present in the target, it will pick those records and delete them into the target, right? So now if I just take an example of employee data in an organization, so there will be new hires, fires, and promotions, right? People will be terminated from services, new people will be joining a company, or people who are there internally get promoted from one level to another. So these are classic examples of inserts, updates, and deletes. So let us say I maintain a current data of my organization and also my master table. So some job is supposed to run and update the master table on a monthly basis, or a quarterly basis, which did not happen from last 2 years. Now you have your current data and the historical data. You can't go and do a comparison by record and say, okay, this person is an insert, this person is an update. No, you can't do that, right? And let us say I also did not maintain any timestamp in this case, right? So I did not maintain any timestamp. So how do you go and handle this scenario? So table comparison is one good transformation. It compares source data set with target data set, and it tries to identify the differences between them and flag them with this insert, update, and delete. The next one is history preserving. So history preserving requires table comparison as a transformation prior to this one. So I'll tell you why. So if you look at this, it says creates a new row only for each row flagged as an update in the input data set. So it preserves the history. So it will not overwrite the historical data, but it preserves the history. So is the reason it is going to create a new row for each row flagged as an update. So what a table comparison does, it identifies the differences, it picks the changed records and mark them as an update, and it will push into the target table. So when it generally gets pushed into the target table, all the existing records will be updated, or the new records, when it is an insert, the new records get pushed. When it is delayed, the existing records will get deleted. If it is an update, the existing records will get updated. But here, this captures the updated records and it will create a new row for them, right? Hope it is clear. Now, next one, if you look at the key generation, for all the newly inserted rows, it will go and generate a specific key number. So it generates an artificial key in a table starting at the maximum existing key values in a table. So let us say if my table has 1000 records, so the new record, the 1001, which is inserted or pushed by the history preserving transformation, will be captured by this key generation. So with this key generation, if there are new records, we can go and capture them. Right, so this is what we can do using a combination of transformations. So let me just go and quickly build this job so we can go and look into the these transformations job underscore history preserving data flow underscore history preserving. Now if I open this data flow, first I need to have, one second. All right. So I'll use the source. Right. So in this one, I gave the city as Hyderabad. So I will first do initial load, and then later I will go to my source and I will change my city from Hyderabad to some other place like Chicago or New York. I'll just change my city, and then if you rerun the job, the Hyderabad record and also the new record will be or should be preserved. So that is the expectation. So when I do these things to accommodate all these transformations, I should have some additional columns from here. Apart from this, I should have start date uh, or from date and to date columns, and also another column called as a column flag, which will I'll just drag the transformations, and based on them I will just go and create the new additional columns here. So first one, if I open this history preserving, so it has two columns, valid from and valid to, and column flag. So three columns I need to create. And for history table comparison, I don't think I need to create any additional columns. No, not required. Right. So my requirement is my target table should have these additional columns. Right. One is valid from, second one is valid to, and column flag. So just give me a second. Right, so I added my source column to my schema out, and the required columns are, one is valid from, that's the date, then I'm just mapping it with sysdate. So as of now I'm just creating a target structure, so I really don't mind what data is there in that one. Then another date column, valid to, and I'll populate that with sysdate. And the next one is column flag. It's an integer. Sorry, it's not an integer, it's a varchar. I populate that with null, and next one more additional column that is required is key. That's an integer, and this is for key generation transformations, but as of now I'm populating that with a row generation. So the basic step that I'm trying to do here is create a target structure with additional columns. So this is my target table, and I'm saving that in my target data store. So just click on OK and connect your query transformation with this one. Validate to see if there are any errors. No errors found. Just run this job. So these are the system configurations that we created initially. Now this creation of the target table is done. So this target table is created with additional columns. One is valid from, valid to, column flag, and S key. Now the second thing that I need to do here is my target table should be a permanent table, because I'm doing a comparison here using table comparison. And in this table comparison, if I need to identify my target table, so only the permanent tables are displayed here. So the basic understanding is, if it is a permanent table and it will not be dropped and recreated. So it has some standard data set in that. So only permanent tables are displayed, like lookup pxt. Only permanent tables are displayed in table comparison. So you need to make your target table as permanent table. So how do you make it? We already discussed about it. Select your target table, right click and say import table, and your table is imported and it's made into a target, right? It's made into a permanent table. You can drag and drop it and make it as a target. Now my source table is available, my target table is available. So I'll go to my options tab and I'll say delete data before loading, because I created it with some junk data which I don't want it to be there. So let me complete the framework now. So I'll use first a query transformation, and in this query transformation I need to create two output columns. One is valid from and valid to. I think valid from should be good, and then I'll go and do a table comparison where I compare my source structure with my target structure. So if you open your table comparison, so this is my table comparison. It is divided into three areas. One is your schema in, schema out, and your table comparison tab. So based on what you select here, the schema out gets populated. So let us go and look at the table comparison tab here. So in the table comparison tab here, so this inputs represents your source structure, and the table name here will allow us to choose your target table. So once you click on this drop down, it will select show the data store, select the table and click on OK. And the moment you select the table name and click on OK, your target table structure is displayed in your schema out. So it is no more your source structure but your target structure. So it's kind of an interview question just to ask you, do you really know about a table comparison? One question that you can get here is, what is an output of a table comparison? So what is the output? It is always your target structure, right? So as per the definition, when I say output, it gives you three data sets. One is flagged with insert, update, and delete, right? So that is a general output. But if they ask you on structural output, what is the output structure of a table comparison? It is always your target. Then generated key column. If your source has any generated key column, you can select that. You can ignore that in our current case. And the next one is input contains duplicate keys, right? So when I'm doing a table comparison, there are three mechanisms in which I do a comparison. So if you look at this comparison method, one is row by row select, cached comparison, and sorted input. So what is a row by row select? So I have first row in my table. So this will go and compare with all the rows of my target table. So let us say 1, and it goes and checks with 1, 2, 3, 4, 5, and let us say the fifth record is identical like my first record. So these two are identical. Then it says that okay, this is present, and then it goes to the second record, and this second record again compares with all the records, and then it finds that the record is already there, but there are some changes in the second record. Then it goes and updates that. So if the record is not present here but it is present here, it will go and flag that as delete. So if a record is present here, it is not present here, then it will go and make this as insert. So this is how a table comparison works. When I do a row by row selection, so when you go by a row by row selection, please keep in mind that you are dealing with less number of data, right? Less number of records, less volume of data. Go by row select, right? So you know that okay, this is my source, this is my target. I have less volume of records in both my source and target, because the general permutation that happens here is, so 1100 into 1000 iterations will happen. So each and every record of my source will be compared with each and every record of my target, and those records are again flagged with insert, update and delete. So these many records will be present in my system cache when I'm just doing a table comparison. So take a call based on the volume of data and based on the RAM that is present on your system. You can do a row by row select. The second one is the cached comparison. So what is a cached comparison table? So it is cached comparison table. So what it will do? It will take a snapshot of this data and and it will try to compare these two. Right? Then in the image of this and in the image of this, it finds any records that are not present. It will mark as insert, update and delete. So existing records but changed, updates, new records present here, but they're not present in the source, mark as delete and insert. Right? So new records present in source but not in target, mark as delete. Then the third one is a sorted input mechanism. Alright, so what is sorted input? So I have my data here as 1, 3, 2, 5. Right, so 1 going and comparing with all the records, 3 going and comparing with here also I don't have the data in a sorted mechanism. Here I have it. But if my source data is not proper, so it will take some time. But if it is in a sorted mechanism, so it is like 1, 2, 3, 4. Now I can go and check it is there, ignore it, then it will go and check from the second record. So I'm doing a less iterations here and I'm trying to improve the performance. So just for performance optimization, you can either go with a sorted input, which means your input data is already sorted on a particular column. So how do you sort it? If you want to go for a sorted input, you go to the query transformation, go by, order by, select your customer ID and sort it according to your requirement, ascending or descending order. So this is what you should do if you are going for a sorted input mechanism. If you don't do a sort in a query transformation prior to a table comparison, your results will not match. Okay, so these are the 3 types of mechanisms that I generally follow. So when I do these 3 types of mechanisms, so these are the 3 mechanisms that we will follow. One is row by row select, then the second one is cached comparison, and the third one is sorted input. Now, when I do have different scenarios of data, like I have huge volume of data, I'll go for cached comparison. I have medium volume of data, I go for sorted input. I have less volume of data, I go for row by row select. Right, so these are the 3 mechanisms that you want to choose. And just in case if my source has duplicate records, right, so it will go again, the same iteration process will happen, right? So to ignore that, if one record is found once, if you want to ignore that kind of a record, you can just check these things or make the system aware that your input contains some duplicates and detect deleted rows from comparison. So generally, if I use a table comparison, just a table comparison between my source and target, so what it will do, it will push these operations, inserts, updates and deletes into my target table. So this is my annotations here on my tool palette. You can just use this to comment. So what it will do, it will do insert, update and delete directly into my target table, which means new records get inserted, changed records gets updated and deleted records get deleted in my target table. So if that record is not here but it is here, those gets deleted. So we read about one transformation where we can manipulate and ignore the deletes, right? So what is that? Map operation. So I can use map operation as a combination with table comparison. And what I can do, I can keep update to update, insert to insert, but delete to discard. if I want to save my historical data on my target table, I can keep delete to discard and then connect it with my target table. Or what I can do, I can say delete to, I can keep delete to delete and just use one more map operation and capture, delete to insert, and put that in separate table if in case I want to capture. So just telling you all possible scenarios, right? The next, our scenario here is to preserve the history of a record. So I'm going for history preserving. So before I go to history preserving, let me complete this. So I'll go for a row by row select here, and I will do remove the sorted comparison here. Select this, right click and delete. Give the hairless volume, I'll go for row by row select. Then once you open the table comparison, input primary key column, right? So the column on based on which the comparison is done. So if I am doing on a customer ID on my source and target, so this will be my key field. So if this customer ID is present in my target, then it is already existing. So in that criteria, what is your key field? So it is my customer ID. And compare columns is a column list that has a tendency to change. One is my address. So I'm going to change my, so let me just look at the data and select the column which I'm going to change. So it is my city that I'm going to change. So here in the compare columns, you will put the columns that has a tendency to change. So in my recent project, which we did on employees and contractors, right, global data consolidation. So that has like a status tendency. So every time there is a change in a record, there is a possible that his status might change. So he can be moved as a permanent employee, right? A vendor can be hired as a permanent employee. Then the second one is the vendor is terminated, his status changes, right? Then existing employee retires, his status changes. So status is one key factor and dates are another key factors. Then his reporting manager is another key factor. So there are, we did a lot of investigation on data. We went column by column and tried to understand like what could be a possible change if I look at the same record after 1 year or 2 years. What columns can be the possible changes. So we drilled down to that level. We sat with the data owners and we tried to explain them, look, hey, look at this. There is a possibility that this column can change in the future. So why can't we include that in compare column this? So I'm just dragging and dropping all the columns that I have a tendency to change, right? So if we have a tendency to change a country, postal code, region, address. So if address changes, everything changes, right? So I have to pull all these columns and drag and drop them in the compare columns. Now, but just for the demo purpose, I'm trying to, add only one particular, change only one particular column data. So I'm just dragging and dropping city here, which I'm going to change. And the filter here, if you want to apply any filters on a table comparison, right? So you want to exclude some data from a table comparison, you can apply those filter conditions here. Exclude a particular data set that satisfies a particular condition. Next, I'll go and use a history preserving. So the definition says create a new row for rows only flagged as update. So in this case, the prerequisite for this is either a table comparison or a map operation. So map operation, I can play around with my transformation. So I can convert normal to update and give it as an input for this one where it will go and capture that. So you guys really need to think like, do I really need a table comparison here? Because you know how to use these transformations, what they can do in and out. Right now, you know all these things. So you should be a best person to take a call like, do I go for this or do I go for this? So if there is nothing to compare, you go for a map operation, convert all the inserts to updates and then queue these updates here, right? Or if you have a data set to be compared and then only capture the insert, then you go for a table comparison and history preserving. So if you open the history preserving transformation, it is divided into three regions. One is your schema out, schema in and schema out. They are defined, so nothing changes in schema in and schema out. Next, the history preserving area. So when I say a history, so this is on updated records. So I have a past and I have my current status. So my past, it says, right, from 2010 September till 2013 March, Rakesh is present in Bangalore and he is a member of so-and-so club. So it has a valid from and to date, right? From so-and-so date till so-and-so date, this guy is present in an organization or present in a club. And after that, he changed his location. So if you generally look at my data, how it will be, it will have the records like from this date, he's a member of this. And next, my changed record will also flow in saying that from this date, this member, he is a member of this. So it is where we capture from and to dates. So remember the effective date that is spoke, it is pretty much similar to here. So here I say valid from, and here I will say valid to. And next, the valid date value. So what will be my valid date, right? So valid to date. It is not valid from, it is valid to date. So if there is no valid date for that, so like the one we did in the effective date transformation, if you don't have any specific date from when it is changed or when it will be changed, so we will define the system date as a system last date as a default date for the new record. But if I have the data change, the date captured, right? So I will use valid from date of the new record as the old record value, valid to date of the old record, or use a day before that. So let us say I moved on 13th March 2013 to Hyderabad from Bangalore. So what I can do is my new date can be from 14th of March or 30th of March. So I can use the same day or day before that one, right? And next one is the column flag. So this will set a value for the newly changed records. It will set it as Y, and the old records it will set it as M. And the column that needs to be compared is my city. So drag and drop city into this compare columns. Validate before you leave this transformation just to make sure that there are no errors in that. The next transformation that I need here is a key generation which will capture the new records, right? So it will first initially what it will do, it will generate a row number from, if let us say I have 100 records here, from 1 to 100 it will generate and load it into the target, and then it will add the new column and additional number. So here select the column S key and give the incremental value by 1, and I selected my target table. Connect it with the target table. Now go to your target table options tab and make sure you have delete data before loading, because initially when I created this, I created with some dummy data. Now I want to delete that. So refresh, and I'm first initially trying to load whatever the data that is there in my source to target. So just execute the job. Right, my job is successfully completed. The first thing, uncheck this box, because next time when you run, you don't want data to be deleted, but you want the data to be captured. Now if I'll just go and filter on ALFKI, right, so city is Hyderabad. Now I'll change it to NYC, right? So I have one record where the column flag is Y and SK is 1, ALFKI. Now let me go and change that in my source flat file. So just let me cross-check the flat file name, ff underscore customer source, and edit ff underscore customer txt. So this is how you generally cross-check on a project level. You don't just go and directly rename the file, though you know it, you will cross-check and rename it. So if you look at this, it's a tab delimited file, and this is Hyderabad present as a value for the first record. So I changed it to New York. Close and save the file. Alright. Now I'll not do any changes to my job. I'll just go and rerun this. So instead of, generally if an update gets into your source, it will go and overwrite the existing value in the target. But in our scenario, it will not happen like that. It will go and do what? Create a new record for this. So now I have both. I'm showing only two records because I applied a filter on that. So just keep that in mind. So I have two records. One is my ALFKI New York, and the old one as Hyderabad. And if you go and look at the value, the old column is set to N, the Hyderabad column is set to N, and the new column is set to Y. And I have total 91 records in my source, and the newly added record is given a value of 92. So this is how your automated delta mechanism worked with a key indicator. So if you don't want all this key indicator and stuff, you can directly use map operation and table comparison and push them into target. So that also works as an automated. But just in case you want the column flags, the keys, and somebody wants to look at the data. It is not just you load them into the target and from there the reports gets refreshed. But just in case somebody wants to look at the data and try to identify what is new, what is old, right, the historical preserving, data preserving, then you can you can go and do these things, right? So this is a transformation, generally a scenario, a combination that you can use in a project directly. So first it starts with a query transformation where it will have a valid from column which will have the side data on that one, just in case if your source data is not having a valid from column. So you'll go and create one here and assign a side date. Then a table comparison transformation followed by a history preserving, followed by a key generation and your target table. All right, so any questions on this? With this we complete the integrated transformations, right? So I think we're done with all the integrated transformations. So any questions on this, please let me know before we proceed to match transformation from quality, because
Hey Rakesh.
Yes, Zafar, go ahead.
I just want to ask, when you are doing the comparison, so it is necessary to use the table comparison, history prevision, and key generation all together? Is it standard
So this is one scenario, Zafar, where you can go and deploy this in any project. It will give a standard result, right? This is a solution. Actually, this is a solution. Like the validations that we saw, the mandatory format and lookup validation, those three validations are a solution, a fixed validation solution. So likewise, if you want to do a comparison and automated delta mechanism, you can go and give this as a solution, where in future if the end user wants to go and look at the data and he wants to identify some inserted or updated records, you can give this. If not, if you want to do a bare minimum structure, we can have a table, source table, a table comparison, and a target table. Only three are enough.
Okay.
So this will do a comparison between source and target, and inserts, updates, and the key risk that you are facing here is this will go and delete the records from the target table. So you don't have any history there. So if that record is by mistake deleted in my source file, or that did not come in my source file, those records will be deleted. So if you want to handle that kind of scenarios, there is one transformation that you can use as map operation. You discard, deletes, and you capture them somewhere else.
Okay, I got it.
Mhm.
Okay. And one more thing, did you get a chance to? I sent you an email regarding interview.
Yeah,
So
I will look into it because I saw the description. One is they're asking about information steward, so which is nothing but data profiling activity that you do prior to your project. So there are two phases in a project, Jaffer. Just to answer this, so it will be helpful for the rest. So I'm just talking about it right now. So
okay,
in a project, there will be two phases. One is your uh, DHA, data health assessment, or data health check, you call that phase. And the second one is your data transformation. So before you sign any project, you just generally go and do some quick validations on the data
uh-huh.
to make sure that the data is in a right shape. So one validation is, all the primary key columns doesn't have any nulls, right? The
Okay,
parent and child relationship between the tables, the integrity check. So you will kind of do some basic checks on this one. So in previous versions of Data Services 3.x, we have a tool called Data Insight. So using which we used to do this DHA activity, and
okay,
in the current version, it is Information Steward. So that is now Information Steward, has got a lot many features, and we can create
okay.
some
So
transformation.
this one comes before you start the transformation or starting to upload the data to
Yeah,
new target, right? So you do the
before
first
you
phase. So the steward is a tool, right?
Yeah,
Is a
information steward is a tool
okay,
using which you can define some rules there, and
okay,
that rules will, using those rules, you will validate the data, and if based on that, you'll generate some stats. So you'll give the stats to the end user and say like your data is ready for the project or your data is not ready for the project. So
okay. So
that stats you create using information steward.
is a we should say is a pre-step before doing anything, right? So we should
Yeah.
make sure that everything is good, then we go ahead, right?
Yeah, exactly.
Okay.
So the twist that I saw in your requirement is you
Mm.
also have SAP as source in that requirement.
Yeah.
So when you generally go for an SAP table, we consider that, the worst scenario, the data is pretty good and we don't need the information steward in that place to go and cross-check the data,
Okay,
right?
I know.
Because when we get the data from a flat file or from a database tables where it is entire data is dumped, there is a possibility that you go and have a bad data. So even I was speaking, sorry, bad English. So I was speaking to Sandeep few days before. So he was also getting some interview, and he asked me for sample questions. So the general assumption that we will have is, if in case you have the data flowing in from flat file or some non-SAP sources where the source system data is bad and the customer himself will tell you that my data
Hmm.
is bad, please go and cross-check before you use it in the project, then we will do some simple validations, right? Is that a primary key column? It has null values. If these two tables have a proper
Yeah.
relationship. So those
Yeah.
kind of things that we will do. So data health
Correct.
assessment.
Okay, but when we are doing handling with the SAP, then it's already fixed, right? So we don't need to worry
Yeah,
about
we
because
don't need to worry about it. It is understood that the data is good because
yeah.
SAP always has the data in a proper structure. It can't keep a duplicate in that one, right? So if it is a primary key column, it cannot either have a null or a repeated column. But database, what you can do is you can create a table, push wrong data into that, and later you can go and convert that into a primary key or a non-primary key column. But on an SAP front, you can't do that. So it is a standard structure into which we have to push the data. So that is
Yep.
the stronghold where we believe that we will not have this kind of bad data where we need some data profiling activity needs to be done.
Okay.
So that is the reason I don't, see a need to use information steward in that case. But
Oh,
just I don't know. Really did not understand if somebody with the proper knowledge gave it or some HR guy who just wanted to give, the description, whatever the tool that he knows. Because if it is a proper job description, people
mhm.
will say like, if somebody asks me to raise an indent for the upcoming project, say 10 people are required, so I'll give them a description based on my project requirement, saying that so I have this project in pipeline.
Uh-huh.
Their source is SAP ECC and CRM systems, and their target is SAP HANA. So people should also know about CRM, ECC, and HANA apart from data services. And this is the complexity of transformation. So they should be at this level in data services. I'll give them a JD. I will, as a project manager and as an architect, I'll go and give my HR team a JD. If I say generally go and find some 10 BODS people and get them to me, I will think if I can need them. So that is a requirement that is pretty vague, right? I'm not pretty sure like if I want them or not. I just want to keep them in a pipeline. So I just said BODS guys, and HR will just internet Google it and say like, okay, BODS also come with business objects and information steward. Now put all these three and put it in the market. So sometimes they just make a meaningless call.
Okay. So do you think the job description is not properly written, right?
It's not properly given. Definitely yes.
Okay. Okay. So
just in case if you get an opportunity to speak to this, as you mentioned in the email, so that was
they will call me for the
call.
screening first. Yeah, generic call. They will call me maybe this week, and after discussion, maybe they will call the technical interview next week. So in the meantime, if you have something like I saw that email, you give a lot of answers. But if it is any precise documents so that I can read or something, if you have, then it will be great for me.
So I did not have any precise document, but let me just do one and send it to everybody in this group so that it will be helpful.
So if you know someone, if they have, then you can provide me. It will be great for.
Generally, we will not maintain Zafar because let me tell you, I lead a panel here. So the general questions that I ask is either from my project requirement to make sure that this guy fits in this position, and the second level I go and ask him is to make myself sure that this guy knows BODS until at what level. So if I want to rate him from 1 to 5, I will ask him questions from 5, a complex one. If he doesn't answer, I'll go for 4, 3, 2, and 1, and I will see where this guy has a knowledge in. Like I will ask at an architect level, I ask at a lead level, I ask at a senior consultant, I ask at a developer tester level, and see if where this guy has done, or has he done anything or not on any project. So I just ask at that level, and then I will then go into the technical discussion. So first one is I want to make sure that if this guy is good enough, he will be a help for me in the project, or he'll be a pain. So frankly saying, this is what I will be checking. Right. So I'll give you some questions on that point. I will draft a mail and send it to the entire forum here. So that should be helpful for everyone in the interviews. Some basic questions at different levels. So if somebody asks you, I'll not mention that level in the question, but I will write them in the order that I ask in interviews, and also a generic project requirement. So it should fit any project. So in that way, I will write it and I will give it to you.
Okay, thank you very much.
Right, thanks, Afra. I'll do that. Right, so.
If possible, please send it to all.
Yeah, I'll be sending it to the entire forum here. So I'll just send it to each and everyone who are there in the list. The next one is we are done with integrator and platform transformations. Next we'll look at the mass transformation. Why Raghu is there in the class. Raghu wanted to know about, so just to introduce, Raghu is my closest friend, and he is an architect of data services. He's from SAP background, SAP ABAP background, and he is an expert on that level too. So he just asked me to walk through on the match transformation. Quality is something that we generally will not go and work on, right? So because for your quality transformations to work, you need to procure a separate license key from SAP. And for you to go and buy some license keys from SAP, you need to be some kind of a partner, channel partner, gold partner, platinum partner. Some stupid partnerships are there. You should be that partner with SAP, and then you can go and procure. So private training centers like us, we can go and communicate with SAP and procure these licenses. The smartest thing that SAP has done is he has left one of these transformations absolutely free, right? So that people, when they learn the quality transformations, they know how they work, and if they get into a company where they really get a requirement to work on the quality transformations and the company will go and procure a license, the consultant will be aware about the transformations, how they work. So let us look at one transformation like that, which is called as a base match transformation, which will help us to understand the rest of the quality transformations, how they work and the pattern in which they are built, right? So let us go and create a new job. So in this job, I am trying to identify two scenarios here. One is my duplicates, and the second one is my potential duplicates. So I think we spoke about this before, but let me do a quick recall on this. So what is a duplicate and what is a potential duplicate? So if I have an employee table, right, then employee number, I gave the same example, so just let me repeat this. So I have a table here, employee number, name, salary and designation. I have employee number 1000, name Samuel, salary is not given, designation is not given. Then I have employee number 1000, name is not given, salary as, let's say 10K, and designation as manager. So I have one more record here as Samuel, 10K, 1000, manager, Samuel and manager. Right, so this is what? Potential duplicates. Right, so because why I call them as a potential duplicates is if you ask the system to go and identify the duplicate, so how will the system identify this duplicate? So, you know, these are the different lines in which I thought about this subject. So that's the reason why I think that I can understand it better, or I can communicate with data services properly. Because, you know, some things when I say I generally ask my people who I do trainings on in my corporate sessions. That should be quite interactive. So I ask somebody like, how can I eliminate duplicates from my table? So one guy read what I'm going to teach today. So he said like, go use query transformation, select distinct. He got some brownies. That's pretty good. Now I asked them what exactly happens on the database. So there's a pin drop silence. There's no question. Like, this is how your database works. So it will take the image of the first row and it will compare the image with the remaining rows, and if it finds the same image, it will flag them, right? So if the same image, which means whatever the columns that are present here, so 1000 Samuel, 1000 Samuel, 1000 Samuel, if it is present thrice, then it will mark them as duplicates. And then we can say exclude duplicates, or so if I say distinct, so it will exclude those records and get only the unique records there. So it will exclude the duplicates. So this is how it happens in the back end. It will take the image of the first record and it will try to compare with the remaining records. Then it goes to the second record and compare with the remaining records. So in this case, how many iterations? 1000 into, if I say my table has 1000, so I have 1000 into 1000 minus 1 iterations happens in my system. So for only one table, right, with only 1000 records, these many iterations will happen in my one table. But if in case I ask my system to identify duplicates, so this image is not equal to this, nor equal to this, nor equal to this one, nor it is equal to this one. So all these columns are identified by the system as non-duplicates because they are not exactly duplicates. The image of one row is never equal to the image of the other row here. So these are called my so what potential duplicates. So one thing, how do I identify my potential duplicates, and how do I eliminate my potential duplicates, and how do I create a best record out of it? So if I create something like this, so along with eliminating the best record, potential duplicates, I give my customer a best record. So that would be absolutely good. So these are the three scenarios that we'll be looking at. One is identify my potential duplicates, eliminate the potential duplicates, and create a best record out of it. So guys, we will take another 15 minutes or 10 minutes for that, so please be patient. So let us go and create a data flow and df underscore match. So I have a separate source file for this which has duplicates in that one. So this is the actual source where I have ALFKI repeated thrice, and one has address and the second one has a change in the phone number. So these are the two columns that are subject to change here. Or the key differentiators from calling them as the exact duplicates. One is address and the second one is phone number. So I just exposed this into a flat file. Just let me look at this. Yep, so this is my flat file. So I have these three records repeated, and for one I have the address, and the second one I have the phone number. So let me add this one. Match source one is the file name. So let me add this one to data services. So I can directly pull it from the flat file, but I think we already spoke about it. So in this service pack 2, DS 4.2, the current service pack, there is an issue. So we have to either go and change the Microsoft Windows Office. So Microsoft Office to a 64-bit for it to work, right? So that's the solution given by SAP, but the guy who maintains the servers doesn't want to change. So let me show one more time. So this can be a good thing. So it won't take much time. So select the folder, right? So now go and select the file. Match source, open. Now go and click on the worksheet. So you should see the worksheet name here, and if you don't find the worksheet, so it will get you an Microsoft Access database error is not properly installed, because data services is 64-bit and your MS Office is 32-bit. So if you get this error, ask your admin to go and change that one to a 64-bit. That should probably resolve. So here we could not do that one, so I'm going for a flat file conversion. So flat file match source, click on the root directory, select the folder, then the file name is match source 1, open it, then it's a tab delimited file, then change the delimiter to tab, then skip the row headers as yes, right, save and close. So I recommend you to practice each and everything at least like 10-15 times. Do it like school days, because you should remember that's how I did that, and that's how I know when to do what. So please don't take it childishly, but practice it more than 10 times. That will really help you. So this is my source, and I have my data here, ALFKIs, with one has the address and the second row has my phone number, and third row it has both nulls, right? So now you go to your transformations tab, expand your quality transformation, right? You go to your match transformation, and match has different strategies in it, right? So address match, then firm address match, name match, then email match. So base match has all of them. So select base match, drag and drop them into this one, your data flow, connect it with your source, and now if you open any quality transformation, this is how it looks, right? So the schema in, which represents your source structure, the schema out based on what you do in your quality transformation, the input structure, the output structure, and the options. So options is the place where you go and actually work on that. And one more advantage. So look at the intelligent levels of SAP. So since they know that these transformations are rarely used and they need to be procured, then only people can use it. He also gave a free notes here. So the moment you go into a tab, input field for the match associated user-defined transformation, there are no input fields associated with the match transformation. The input field tab, you will need to add the input fields that you want to use in this transformation. So I want to use my company name, right? And then I want to use my address and phone number, and also my postal code. So these are the fields that I want to use in my strategy, my match strategy here. Now if you go to the output, it will say output fields, the following match fields and generated by the match transformation. So it sees the field name, description, the definition, default, content type, and the definition. So if you just drag and drop it a bit, you can see it properly. So if you want to take the help, you can go and take the help. So whatever the options that are there, it will show you each and all what you need to do, what is a match score, what is a match status, and all these things. So if I go to options again, this will change and it will give me what are the things that I need to do in the options. So just for a better understanding, let me take you through a wizard. Now select the source. One second. So select the source table, right click, and you get something called as run match wizard. So go through this wizard. So what are the different types of, I'm just taking you through the wizard so you understand it properly. So select match strategy. So first one is you need to select a strategy on which you are trying to identify these potential duplicates. So it should be on one column where you can go and identify this potential duplicates. So select match strategy. The match wizard begins by prompting you to choose a match strategy based on your business rules requirement. The path through the match wizard depends on the strategy you select. So based on whatever you select, the path on which you are selecting this one will change. So let's go with the simple match here. So based on the strategy that you select, the subsequent steps will change. So it can be as a consumer householding strategy or a corporate householding strategy, multinational consumer strategy, or identify a person, multiple ways to find the overlap. So what are the different ways in which we can identify a person? By his social security number, by his phone number, by his email address, by his bank accounts, right? So different ways in identifying. So these are the different strategies that we can pick here. So one is my simple strategy I want to go with. So I encourage you to read or do the next strategies, at least read them so that they'll be helpful. Second set is identify the match criteria. So how many sets you are making here to identify this match. So I can do it in single set or I can do it in multiple sets. So if you want to do multiple sets, you can add them here. Or you want to do that in a single set, you can do that using single set. So here in my case, one single set is enough. So match on what? So these are the different types. So I can do a match on a full name of a person, first name concatenated by last name, the address, given name 1 and 2, given name 1, family name, phone number, identification number like social security number, PANs or passport numbers, whatever it is, email, company name, date, latitude and longitude where this person is present, and custom you can define your own. So here I have a data in which my company name is present, so I can go and give the firm name and compare using two types of similarities. One is your field similarity and the second one is your word similarity. So when I say field similarity, it goes by that particular column properties, and word similarity go by what is present in that particular column value, the value of that particular cell. Right, so if you want to give this one and just click on next, and then you map your firm name with the input source structure. So company name is my input source column name, and I'm trying to match with my strategy, which is firm. Then break key. So what is a break key? So if let us say I have huge volume of data, and if I want to identify this particular company name within that bucket, so it will be pretty difficult for me to do that because my company can be in different regions. So if I break my data based on postal code, right, it will be pretty good for me to search within that bucket. So because one postal code has one company, like let us say my company is present in Hyderabad, Delhi, Gurgaon, Mumbai, and so on. Right now, what I will do, I will try to break that into or put that into a bucket by segregating that by a postal code. So now in Hyderabad postal code, there is only one company where I can go and do a quick search within it, right? So I can do that using a postal key. So I can click on the drop down and I can select the postal code here and just finish. So this is a simple step. Now if you go and open this one, now you need to drag and drop because you worked on the postal key for the this one. So this is present. The other columns you need to drag and drop them. So company name, drag and drop it here. Then the address, you'll be working on address. Oh, so this is mapped. So just delete this. Get the postal code. Right, get the address and the phone number. So these are the columns on which we'll be working, right? So these columns are already getting populated in the output. So what we can do is go to this column, select phone number and address especially. I want system to identify this. So I can do that a little later. Right, so now if you go into this options, get and edit options, you see the work is already done through the wizard. So break group, you did it on a postal code. Then level 1 match criteria, you did it on firm. So if you look at the match criteria, match score is 78%. So if 78% of data is matched, then it will go for a match tag. If not, it is a no match, right? So the column on which we are doing a comparison is a firm name, which is nothing but my company name, and this is my match strategy here, and just click on apply. Okay, and now let us run this one with creating a target table. Target match and validate this. Now this is step 1, identify your potential duplicates. When I know which record has my potential or which records on my source has my potential duplicates, so I'll just go and directly apply a filter where my customer ID is equal to, then what it is, ALFKI. My 3 records are there. One has address and the other has a phone number. Now my system identifies my potential duplicates. So group number 1. So this is first group of potential duplicates, and the match score here is 200% for 2 rows and 1 is null. And if you look at this, there are 3 records in this group, and 1 is the master, and the remaining 2 are my subordinates. So first picked is my master, and second are my subordinates. So I can give a where condition saying that where the group rank is not equal to yes, so I can eliminate all my duplicate records, right? Is that possible? Yes. So I can avoid all my potential duplicates, and I can only pick the first picked is master, so there is no specific reason why it is called as master. Only the first picked record is called as masters, and all the subsequent records are called as subordinates. So in other database terms, we call this driver and passenger records in SQL especially. We call them as drivers and passengers. So the first one is the master record, and all the remainings are subordinates. So I will use a where condition saying that where this is not equal to yes, right? So all my subordinates get kicked off and masters will get loaded. So the reason why I'm saying where it is not equal to yes is, so if I say only it is equal to m, so there are some unique records which don't have a master and subordinate, right? So in those cases, what it will pick only one record which is marked as master. So I'm saying which are not equal to yes. So it can be master or the other records, right? I can pick all the remaining records to my target table. Now this is step number one. I identified my potential duplicates. Then second step, using a where condition, I can eliminate my potential duplicates. Then third step is my best record. So I don't want to give the data like this to customer. Since I identified this, how about posting this from here to here and this from here to here and give a complete master record? So that is a post-match strategy that you need to do. So go to your options, edit options, right? So post-match processing. So select this, right click and go for add, and you get a best record here. So best record is a strategy. So br underscore phone. So we need to do it for two columns. One is your phone and the second one is your address. So best record phone, the strategy is non-blank. So if my strategy needs to be satisfied, so the condition here is that particular record, if it is a best record, it should not have any blanks in it. The strategy field here is a phone number and posting destination. So now I told you, wish I can post from here to here. That is possible. One is you can post to masters, or you can post to subs, or from masters to subordinates, or everywhere, post it everywhere. Then you can select distinct option in the query transformation. So I'm just posting it to masters, and post only once per destination, keep it to yes, right? And source field here, you need to select as phone, and automatically it will pick the destination. If you want to do a custom program, so it will open a Python script editor, so you can apply on this one your code if you know the Python script, but we don't know that, not even required. So just go for no and select the source phone column, right? Just make sure in data services you need to make sure that you click on apply when you do changes so that they stay. If not, they will not, since you are working on metadata. So BR phone is there. Then the next one is best record address. Then the same strategy, which is non-blank. So you can use any of the strategies based on your requirement. So you just need to think about it. Then this is my address. I post it to masters. Then post only once per destination as yes, and then go and select the address and destination field as address. Click on apply, and I have two best strategies here. Now I will go and rerun my job, because earlier I just did a strategy in identifying my potential duplicates. Now I also did something else where it will post from my master to subordinates. I'm just refreshing this. So did the posting here, but I just did not select this one. So once you do any strategy, keep this in mind. You go and delete, because this is directly mapped to your source. Whatever there is in the source, it will be displayed. So select these two and delete them. And now what you can do is you can check these two. So these are the calculated columns, the converted columns. So check these two in the output tab and go and rerun the job. So any quality transformation, keep in mind, so Raghu, this is for you. So any quality transformation, keep in mind, first you need to go and work on options, input. So drag all the columns that you need to work on this strategy, right? The company names, the postal codes or address and the phone numbers. And then go to the options, work on those options, and then output. If you want to display the converted columns, you need to select them here, delete them from here, and select them from here. Okay, so now if I refresh, I go and see my two columns that I selected, are displayed here. So the address is posted from address to address, and my phone number is posted from here to here. Right, so I see both the columns are now populated. Now what I can do, where I can select this one is not equal to yes, and I can ignore all the stat columns here. So these two values are populated, and just let us say, just to look at the complete data, I use a query transformation. I mean, just to check the completeness of the data. Rank as masters. So in the where condition, so these are my stat fields, additional fields that are created. So I drag and drop that and say where is equal to m, right? Just to check the completeness of data. Map to output. And these two fields and say map to output. Right, so now you see a proper record, right? It has, one single record rather than getting multiple records. Point number one, we eliminated potential duplicates. Not only eliminated, we also created a best record with address and phone number from different rows pushed onto the master record. So this is a match strategy, right? So you identify the potential duplicates, point number one, and second one, you also load the data from your subordinates to master at a column level and make a best record. So this is our match set. So any questions on this, guys? I'm sorry for extending it today. It took 2-hour session. Alright, so I believe right now we'll not be having any questions because kind of different things that we are looking at every day. But my sincere request, please go through these recordings, and if you have any questions, please stop me before we start our session tomorrow, and go ahead and ask me your questions, get them sorted out. If I have answer, I will answer them immediately. If I still need to go and check back on the system or read about it and let you know, so give me a day's time, I will work on that and I'll let you know. So we're done with the transformations, and next one we will be looking at is the management consoles. So what are the different admin activities that we can perform? How do we schedule our BODS jobs? And at an architect level, at an admin level, or sometimes, in some projects they really don't care if you're an architect or if you're an admin, they want you to do each and everything. So for those kind of projects, I'm getting you ready. So, we will look at both the management console, central and data services management console, right from user creation to deployment, we will see. And after that, we have real-time jobs, one session, then introduction to SAP HANA and how can we load data into SAP HANA using data services. We'll also talk about the HANA architecture and introduction to HANA. Then we will have a project orientation, the BPDM's best practices for data migrations, the methodologies, AIO and BPDM. And currently we also have something as a new form of BPDM, which is called RDS, Rapid Deployment Solutions. And after that, we will talk about a project, my recent project, where we did something additional to what data services provide. So there are some things that SAP has promised to look into them in the future, Q4 of 2015, but we kind of had to do that, so we used Windows script and some other extra authentications. We also did automated email notifications through BODS, so I'll walk you through all those things in this project session. We will discuss right from sales call to post go live support, which is nothing but hypercare. So look at all those different phases where what person plays what role and what will be his roles and responsibilities. We'll be looking at all those things, right? So probably in another 4 to 5 days, depends on your questions. Please engage me more. That's what I want you to do. Depends on your questions and interactive sessions. We will take it forward and we'll look at the project orientation and all the stuff. Alright, so thank you guys. Thanks for joining today's session, and hope to see you all in tomorrow's session. We'll start at sharp at 6 a.m. IST, so please be on time. Tomorrow we have multiple topics to cover in the management consoles. Alright, so thanks for your time. Zafar, you have any question?
Yeah, actually, I was trying to use the repository manager, and there was some option missing when I was selecting after creating the database.
Yes, this is repository manager, and yes, you're trying to create a local repository?
Yeah, I did that one. It was okay, but the other one I forgot.
Central repository?
Yeah, I think central repository.
So if you go and select the central repository.
No, not I'm talking about this one. If you go back to, you showed me the 5 steps, right? When we create the local repository. So I create the database and I created that one. And right after that, when I was trying to create the, I forgot, I think the 3rd step or 4th.
It's a job server. You go and either create a job server or add your local repository to the job server.
Yeah, I think the
so
third
not
one,
all the systems will have an access to create the job server. Since I had to teach that, I picked that option. So one option you'll definitely have is to go to your server manager.
Okay.
And here you click on configuration editor. So you'll not have this add option. It can be grayed out. So you go and select job server 1 and click on edit. And then you can add your local repository to that one.
Yeah, so when I was selecting this one, it was disabled.
I'm sorry?
This option was disabled. This option disabled in my login ID.
So it's not even giving you an add option here?
No, nothing.
So select the job
There was
server.
only, I think, three. Yeah, I was trying, I was watching. I think there were only 3 options. I think job server 1, and there was another one, BODS, and the 3rd one I forgot.
Yeah, the system you are working on is a different system, definitely yes. That's a different server altogether.
Yeah,
so that will have different things. So select the required job server.
Yeah, but there was no.
So Jafar, your voice is fading out. I'm not able to listen to you. Okay, just let me tell you the process here. So, I mean, it depends on server. The server you are working is different from the server on which I am teaching. So you have this difference. So here I have multiple job servers, and there you have a different set of names. So whatever the job server to which you want to add your local repository to, select that one, click on edit, and here you have to add your local repository to that job server. by selecting the database server name, the database name on which you created your local repository, the database username and password, and just click on apply, and it should be added. And if it is not adding up there, or if it is not giving you that provision, I recommend you to take a TeamViewer session or a Skype session with Ravi. So Ravi will be the best person to help you out on that creation, because Ravi was given a complete admin access on that server. So just in case if you lack any authentication, he will provide you that authentication. Any more questions? So, all right, guys, thanks for, sorry, yes? Raghu, you have any questions to me? All right, guys, thanks for joining today. We'll connect back in tomorrow's session, and, I'll try to sort out your questions if you have any tomorrow. All right? So, good night and good day, guys. Have a good day ahead. We'll catch up tomorrow.